Good evening, folks. Well, this is just a short introduction to this video, which covers why some people think the Earth is flat, and most people, of course, think that the Earth is a sphere. And why do they think it's a sphere? Why do they think it's flat? Now, just a reminder along the way, please press the like button or the dislike button, whatever floats your boat. And if you haven't already, I would appreciate it if you press the subscribe button, and also that little bell will remind you when I'm next doing a video. But importantly, please stay to the end, because that is where the punchline is, and I'm sure that you'll enjoy this video all the way through, and especially at the end. So I look forward to you seeing it. Let's get on with it. Well, good evening, folks. Well, it's been about a week since my last video, and I've had occasion to come across the hornet's nest of flat Earth. This is where the queen of flat Earth lives. This is where all the drones come. Really, the hornet's nest of flat Earth. This is where they get their instructions from. So they come to this place where this really loud queen is, and this queen dispenses the order of the day. So the things that the soldiers are required to tell their flock, like a school for the preachers, if you like, a school for flat Earth preachers. So this is where you work out how to deny that gravity is a thing, how you need to insist that gravity is not a force, what you need to deny, what you need to accept. All of these things are determined by this queen in this place. Now this is a bit of a riddle, so you figure out what place I'm talking about. This is where all of these, where all the flat Earth drones go to before they spread out to their flock. Okay, anyway, it occurred to me, thinking about them, that one would legitimately ask the question, why do people think the Earth is a sphere? Okay, what good reason is there? And if you believe some of these drones, and certainly this queen, then really there is only one reason why ordinary people think the Earth is a sphere. It's because when they were little, the teacher had a sphere on their desk, you know, a globe. And that's the reason that they believe it. It's because of this globe on the desk. That's what they tell the flock anyway. Okay, so I thought I'd have a little bit of fun with this. So I got my Earth over here on my whiteboard, and a few words spread around the place. Now let's have a look at some of these words, because actually these are the reasons why people think the Earth is a sphere. Let's go through some of them. I'll go fairly quickly, otherwise this will be a very long video. And actually I just want it to be quite short. Okay, here goes. Right from here. Well, the ships. The ships going over the horizon. That's kind of a clue. So anybody would be looking at that would be thinking, hang on a second. Those ships, they ought to be going smaller and smaller and smaller in the distance. How come? They just seem to disappear from the bottom down. Okay. Having a look out at the windmills. Where is half the windmill gone? I mean, come on. You only need to be a child to look out there and you can see that half the windmill's gone. You know that they're not in the water. Okay, so you know that there's something going on there, right? Is the Earth a sphere? Well, that's pretty good evidence. Let's try another one. I better hurry up, otherwise we'll be here all night. Structures, like I just said. Okay, like the windmills. What else? Oh, the horizon. Well, like if you think about it, how can there be an abrupt horizon if the Earth wasn't a sphere? There is something there that prevents you from looking any further. That's the horizon. It's quite abrupt. So, surely that's a pretty good reason for thinking that there could be a curve there, especially if you go high up and you can see a bit further. Go higher up and you can see further again. Okay. Sunset. Well, I'm sure most people have had this romantic moment where you're out there on the beach watching the sun go down. I certainly have. And the sun just goes down as if it's sinking into the water. Okay, it doesn't go away. It goes down. It doesn't even change the shape of it. It just disappears. Now, if you go higher up, you get to see it again. Wow. Now, a thinking person would be wondering about that and saying, well, you know, that sun's not going away from me. That sun's going down. Well, you know what? That's why they call it setting. That's why they call it the sun is setting. Because it's not going away, it's setting. Setting meaning going down. Okay. Sunrise. Well, you know, like that's the opposite, yeah? So if you watch the sun going down, and you're lucky enough to live sort of in the east, yeah, you'll see the sun coming up over the horizon. And you know what? It just seems to just come up straight out of the water. Well, it doesn't sort of a little dot all the way over there, and this little dot's coming right towards you a bit at a time, getting bigger and bigger and bigger and bigger and bigger until it's upon you. Oh no, it's right out there. You see the tip of it. Then it gets bigger and bigger and rises up above the horizon. And then keeps going all day, all around. Doesn't change its size. Above your head, all the way down until, guess what? Sets. Now, a thinking person ought to look at that and think, well, you know what? Maybe I don't know whether the sun is going around or whether it's the earth that's moving. But I do know this much. It's spherical. Okay. Star trails. Come on. You know that it has to be spherical for that to happen. Okay? There's no way knowing you're a flat earther and you haven't seen these star trails. Don't fib to me. Okay, the moon face. Now come on, you know that we only see one face of the moon all the time. Yeah? Alright? That's a serious problem. If you don't think the earth is spherical. Yeah? How else could it happen? I mean, let's say the earth was flat. Alright, let's just accept that the earth is flat. Well, people on one side of the moon would see one face of the moon, and people on the other side would see the other face of the moon. You know that doesn't happen, right? That must be a tough one, eh? Okay, what else have we got? Well, you know, while we're talking about the moon, You know there are retroreflectors on the moon. Yeah. Right from here, they have pulse lasers. You know, they can actually shine a pulse laser at the moon and get the pulses back. You know why? Because there's a bunch of retroreflectors on the moon, like mirrors. The beauty thing about them is you can actually shine the laser from any angle and they'll come back to you. Okay, so they won't be deflected out somewhere else, which would be a problem, of course, if you didn't have one of these, because you shine a laser at the moon and then the moon's surface would have it disperse everywhere, right? You wouldn't get it back. But this little beauty, there's a few of them, they designed especially so the beam will come right back, no matter what angle you shine it at. Cool, eh? All right. What about Polaris? Come on now. You know they've been looking at that thing for years, like centuries. You know why? Because they use it for navigation, right? Okay? And you know that you can tell your latitude with a sextant by looking at this. And you know that doesn't work on a flat earth, don't you? Huh? Who do you think you're fooling? Come on. Okay, what else have we got? The Southern Cross. Well, that's pretty much the same problem, isn't it? Yeah? You see, over here in the Southern Hemisphere, we have the privilege of seeing the Southern Cross at night. I said Southern Hemisphere. You know why I said that? Because even the people in Cape Town get to see it. And you know something? We get to see it at the same time. 120 degrees apart. So, they're over there, a long way away, and we're over here, 120 degrees apart. And you guess what? We look at the same stars. The same Southern Cross. There isn't a special Southern Cross for the people in Cape Town and the people in Australia. It's the same thing. Okay. I'll let you think about that one, hey? Alright. The climate. Now, I know this is really pressing, but you know something? The way the climate works, with hurricanes going one way because of the Coriolis, and hurricanes going and cyclones going the other way. You know that can't happen, hey, on a flat earth, don't you, hey? What must that take for you to bullshit to yourself, eh? Come on. Let's carry on. Oh, the Great Circle routes. Isn't it strange that you can get from Santiago to Sydney in just 12 hours, eh? In an aeroplane. And you know they don't fly that fast, eh? Oh, I've got a better one for you, actually. It's got to do with the sun. You know something? If the Earth was flat, you know where I live? Would be around 72,000 miles. Would be the circumference. You know what that means? The sun has to go 3,000 miles per hour. Well, you know our Aussie cities are pretty big, but they're not that big. The sun would get over us in about 10 minutes. I assure you, the sun is in the sky for a lot longer than 10 minutes. Okay? So come on now, you know you're wrong, don't you, eh? You're just pulling our legs. I know it. You know it too. Okay. What else have we got? Oh, let's go back up here. Force. Well, you know something? If you put something on a scales, it presses down on them, doesn't it, eh? You know this pressing down? We call it force. Yeah. That's the word for it. And it's a real thing. Direction. Falling! Wow, falling. That's a biggie. Falling is a biggie. Hey? I know you try to deny falling. I mean, we laugh about that one. Okay? I mean, things actually do fall, don't they? You can call them what you like. We call it gravity. But you call it what you like. It's cool. It's still going to fall. Whatever you call it, it's still going to fall. And you know something? It's going to accelerate. Accelerates at 9.81 meters per second squared. Yep. Yeah, that number. Yeah. And you know something else? If the air resistance doesn't affect them, they all fall at the same rate. How cool is that, hey? Everything falls at the same rate. Wow. That wipes the density nonsense out of the window, doesn't it? You know that, don't you, sleeping warrior, hey? You're not fooling us. Okay. Let's have a look. Triangles. Triangles. Let's see how you get to have a triangle on a flat plane that has more than 180 degrees. Hey? The corners that each corner, add them all up together, comes to more than 180 degrees. Now I know that's pretty special for you, sleeping warrior, because triangles are not your thing, are they? I heard. Hey? 1, 1 and 1? Never mind. I'm sure by now you've figured it out, eh? Triangles have 180 degrees, don't they? That's how much the angles add up to. Right? That's if you're on a flat surface. But you know something? If you're on a ball, you can get more. You get more than 180. You can get 3 lots of 90 degrees. How cool is that? And you know something? That happens. See if you can get that on a flat earth. That'll be something. Okay, what else have we got? Oh, space exploration. No, I know you think that's nonsense, don't you? Hey? I know you think that every week a rocket goes up and they just go dump it into the sea, like, you know, millions and millions of dollars worth of rocket, you know, hundreds of millions of dollars. And every now and then they say, you know something? Isn't it time we fooled a bunch of flatties? Hey? It's time to fool the flatties! Let's dump another $100 million in the sea. See how they like that. Hey? Sometimes it's the Indians going to do it. Sometimes the Americans will do it. Oh, and the Russians, they have their go too. We all have our go at dumping a rocket in the sea. Just to fool the flatties, eh? Okay. Satellites. Yep. Well, I think I've told you before. I've got a dish on my roof. Had it there for about 12 years. And you know what? I was there when the guy put it up there. I had a special interest in it. In that dish going up on my roof. Okay? I was particularly interested. So I waited for him. Turned up, got the satellites, we had a good yarn about it, obviously. And he put it there, it hasn't moved since. And I get television. He explained to me how he worked it out. It was cool. So, satellite dish is up there. What do you think it's doing up there, hey? Bet you have one on your own roof, hey? Were you there when they put it up? Maybe. Bet you're not telling us though, are you? Flatties. Okay, photos of Earth. Well, for goodness sake, I have a whole lot of them. Okay, you know those satellites, the polar satellites, that's pretty much their job. Take photographs. These days they're so good, they can take a 4K photograph, 300 by 300. That's pretty good. It's like there's no place you can hide from one of those. Yep, that's their job. I'll tell you a little secret. For them to take those photographs, it takes about 12 hours for this orbit to complete in such a way that it takes a photograph of every square inch in those 12 hours. And it needs the Earth to spin underneath the satellite. Satellite goes around the poles, about 5 degrees off, and at the same time the Earth is spinning beneath it. It's worked out with exact precision. How good is that, eh? And all that hard work, and all the Flatty has to say is, nuh-uh. How good is that? Alright, what do we got? Well, you know, that's orbits. That's got to do with satellites, isn't it? And what do we got here? Ionosphere. Whoa, ionosphere. That's a big word for you Flatties, isn't it? You know what? See this? Radio. That bounces off the ionosphere. Hey? Do you reckon there's one of those on the flat Earth? An ionosphere, you know, so that you can go around for miles and miles and miles, bouncing off the ionosphere. Hey? Don't think so. Okay, planets and stars. Well, you know, I know Flatties don't know this, or they pretend not to. I'm pretty sure those ones in the hornet's nest, they know though. Planets are a thing. You can watch them with telescopes. And guess what? You can see that they're round too. Hey? And if you look at the moon with a telescope, you can actually see the craters. You know that they're round. Hey, listen, come on. Don't bullshit to yourself. You know it's not a disc that's got its own light. You can see the craters. You can see the shadows in the craters. Who the hell do you think you're fooling? It's just yourself. Don't be silly. Come on. All right. Then we have, what do we have? The gradient. Atmospheric gradient. That's because of gravity. Okay? Gravity holding this atmosphere down. And what's this bullshit about not needing a container for gas pressure? We're not talking about the same stuff. Okay? When we're talking about the atmosphere and the gradient, we're talking about pressing down. We're talking about the atmosphere being held down to the ground. Because everything that's got mass is going to be pulled towards the Earth, the center of Earth's mass. It's heading that way. Okay? It's gravity. Now, I'm not going to sit here and stand here tonight and explain to you, you know, about Einstein's work and compare that to Newton's work. I'm just telling you that stuff falls, you know, like you see this pen here, if I drop it, it'll fall. You know why? Because it's got mass. And you know something? Even the air has. Okay? If you're not sure whether gases have mass, well, you know, you could freeze some carbon dioxide, about 1 kilogram's worth, and then drop it on your foot. And then come back and tell me that carbon dioxide doesn't have mass. I'm sure you'll have me in stitches. Okay. What about motion? So gravity isn't a thing, hey? How do we get to work out motion, projectile motion, circular motion? How do we get to figure that out? How do we figure out if I drop this pen, how long it'll take to hit the ground? How do I figure out if I throw the pen in the air, how far will it get? And how long will it take to get back? You think I have some magic? No. I calculate it. And guess who helped with that? Newton. Yep, it's been a while, but the stuff still works. Every bit of it. Remember I told you about the satellites? It's thanks to Newton and Kepler that they work. Still their stuff. No one's been able to top their work yet. Not even Einstein. Okay. Alright, what do we got? Space, we spoke about electromagnetic spectrum. Well, you know something? I put that up there because of the sun. Yep, that's right. That thing that shines on us all day. It gives out this electromagnetic spectrum. You know that bit we call light? Yeah? It's got Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. Yep, that's the electromagnetic spectrum, and that's a tiny, tiny, tiny slither of it. Alright, there's huge amounts either side of that. All the same stuff, you know, photons. They come from the sun. And you know something? It's because of the activity in the sun that we get them. Alright? Now, this isn't the video where I explain to you how that happens. Alright, this is just a bit of a fun video to tell you why most of us, like 99.999% of us, believe that the Earth is a sphere. Well, we kind of know the Earth is a sphere. I mean, oh, for goodness sake. How many things do we need of these things to prove it? Hey? I mean, this is pretty convincing, isn't it? Alright. Okay, what else? Okay, well, I have a look here. S and P waves. Okay, you know something? That's how we know what the Earth is made of. Okay, so that gives us a chance of a model to work out, wonder what's underneath the Earth, what's underneath that crust. Well, earthquakes, they help us figure it out when we can check how these waves work. Transverse waves, tectonic plates. They're a thing. I know you like to think they're not. But you know something? Who do you think you're fooling? Measurement! I mean, you know, like, they have measured the thing. Okay? There's surveyors all over the world. They get measurements from sea level to the top of mountains. Okay? They get all sorts of measurements. You put them all together. Hey, Earth's a sphere. And then we have the good old magnetic field. Yep, we do have that. The good old magnetic field. I'd really like to know how that could happen if the Earth was flat. Actually, you know something? It's cool. The Earth is a sphere, and that gives us the magnetic field. The fact that we have these eddies going around in the outer core. Thankfully, because if we didn't have a magnetic field, we'd be in some serious trouble from cosmic rays and stuff. That's how we get protected from it. What do you reckon happens on this flat Earth thing, eh? I'm going to show you now. You see all these words here? I wonder how many there are. 1, 2, 3. Oh, I forgot GPS. Never mind. You know what that is. Horizon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, I reckon. Around there, let's just say around 30, eh? Different things. Plus the stuff in the middle. That's how many things that people think about and why they want to think that the Earth is a sphere. Okay? So, I mean, like, you got to admit that's pretty convincing, eh? Alright, I'm going to show you what you get if you think if the Earth is flat. Let's list some of them. Okay, So I'm going to rub this all off now. What a shame. It was fun putting it together. Now, here we go. Now I need to rub it off so that I can show you the evidence for flat Earth. Right there. I'm kidding. I'm kidding. I'll just put it up here. There you go. That's it. Your evidence. It looks flat. Wow. Put that up against those 30 items that I had before, hey? Seriously, come on. Who do you think you're fooling? I know you're all pose, okay? It's a bit of fun, let's face it, okay? Yep, the hornet's nest over there, well, that's serious business for them, you know? Because sadly there are people who actually do think the earth is flat, and they give these people money. But I had a little discussion with a couple of them actually. I asked Sleeping Warrior, straight up, do you believe the earth is flat? And you know what he said to me? No. He said, there's no science for it. Guess what? He's right. How good is that, eh? And guess what? I asked Nathan Oakley that question too. You know what he said? Well, hey, it's content. What's wrong with people paying for content? There you got it. Alright, that was a bit of fun. If you like my videos, go on, press that like button, hey? And if you didn't like the video, come on, you got no sense of humour. Never mind, press the dislike button, come on, smash that thing. And if you want to see more of these videos, press the subscribe button and that little bell, and I'll come and do some more. Okay? Cheers!